Hey guys, it's Phoenixman 1015 here. Happy to start part 17, even though it's been a very long time since I actually started the last tutorial. So long, in fact, that I'm actually going to do like a little bit of a refresher. Now, if I recall correctly, we've been dealing with two types of equations so far in this tutorial. We have this equation, this kind of equation. I'm just going to do them real quickly, just in case you guys don't quite recall how this system works. So we have our order of inverse operations, if you might recall, which would be SADMEP, stands for subtraction addition, which would be together, division multiplication together, and then exponents, and then parentheses. And we also have our order of operations, which is, I don't know why I drew that there, that'd be PEMDAS, which would be parentheses and exponents, multiplication, then division, and addition and subtraction. So we have to use our order of isolation properties to isolate the variable, which means to get it by itself. So let's use our SADMAP over here too. First step, subtract or add. So we're going to do that. And then we get 2x equals 12. Next step, divide or multiply. So we're going to do that, divide by 2 on both sides. And then we're going to wind up with 6. And another thing that I might have taught you guys, I don't remember if I did or not, you can plug this variable just right back into the equation and see if the number on this side matches up to the number on that side. So we're going to do that real quickly. 2 times 6 plus 4 equals 16. Okay, so what we're going to do now is, after this is done, we're going to want to multiply these two. 12 plus 4, 16 equals 16. Yep, that looks good. Okay, so we've basically been dealing with a lot of that recently, but I wanted to go over something else before we start our next little unit of big concern. And these are the properties of addition, or additive properties. Properties of addition. I don't care about quality anymore. Yeah, you know what it's trying to say. Whatever. So we have six properties. I believe it's 5. Whoa there, I'm getting too excited. Only 5 properties. We have the commutative property, and I'm going to abbreviate these. I'm going to go into them later. Associative properties, identity, inverse, and then 0. There's only one property. I don't know why I was saying properties. There's a lot of properties of numbers, and you're going to get them all over the place. But for the purpose of pre-algebra, just need to know these 5. Just keep them in mind. Actually, you really only need to worry about the first 3 or 4 of them. Okay. So let's go ahead and start with the first one on the list, commutative. Now let's say we had 3 variables. I'm going to give these variables names A, B, and C, and we don't know what these values are going to be. In fact, you need to have a lot more equations to even have a guess of what it is. So what we're going to want to do right now is apply the commutative property, which basically says that these variables numbers can commute or move around as long as they have an addition sign binding the two of them together. So from this we can get A plus C plus B, B plus A plus C. Cab, we can have a bunch of words as long as we have the plus sign. So we can't get rid of we can't get rid of this. We can't just say C plus A and be done with it. That doesn't work. And we also can't add or subtract things in between. It doesn't work. Commutative property basically says you can move them around so long as you keep the addition next to them. That's really all it is. Associative property, this is the next one. Let's say you have the same 3 variables, A, B, and C, and if you want to add them together to combine them, naturally you're going to want to do the first 2 first, but the associative property says in theory you can even do the last 2, and you can use a commutative property, move these numbers around, switch C and B, and then do A and C first. So these properties can be used together. They're true facts and they always work. And I'm going to prove 1 or 2 of them at the end of this tutorial. Okay, next we have the identity property. So we had the commutative property, which means we can move around, associative, which means we can associate them differently, and now we have the identity property. Let's say we wanted to add something to this side of the equation, but we still wanted to get the same value. We still wanted to keep 6 on both sides. Well, the identity property says that if you just add 0 to a side, technically you want to add it to both sides, but there's no point in doing that because the identity property just says that you can just add 0 to one side and you will get the answer, which makes sense. If you don't add anything to 6, it's still going to remain 6, but you're still adding 0 to it. So 0 is really fun to find out about 0. 0 is actually a concept. It doesn't really exist in real life. You can't have 0 as a number. Anyways, then again, you can't really have any numbers, but that's going way into it. Alright, so next we have inverse. And inverse basically means the opposite. Now, let's say we had 6 again, and we wanted to get to 0. We wanted to completely negate this 6 out of this scenario. And we wanted to add something to it. What could we do? Well, we know that to get from 6 to 0, we're gonna have to, what was I gonna say? Alright, if you want to get from 6 to 0, you're just gonna subtract 6, but we can't do that. 6 plus 6 equals 0, but we want addition. This is where the rewriting subtraction, which basically means adding a plus in front of the negative sign, will work wonders. I don't know if I explained this or not, but you can basically subtraction is adding a negative, so you can just say plus negative, and plus negative can be changed back into plain old subtraction, in case you didn't know that. So we can just add a negative 6, so basically adding a negative version of a number. So 7 equals 0, adding negative 7, x, adding negative x, and that will always cancel out to 0, always. Except for real numbers anyway. And the last one is gonna be the 0 property. Basically, adding a 0 to a number will keep the number the same. Basically, the 0 in addition equals the identity property. Doesn't always equal the property though. Just in addition. And subtraction, but we're not going to go into subtraction properties, too many of them. Okay, so I've given you all of the properties. Let's see if you retained any of them. What does the community of properties state? When I show this, what's the community of properties say we can make it equal to? I feel like Dora. It'd be cab right there. Yeah, you can just move them around. What property am I exemplifying right here? Which property? That'd be the 0 property, correct. Let's say, which property am I showing now? That'd be the associative. And let's say, let's do one more. Which one is that? The inverse property. Alright, let's go and prove one of these, because I bet you think that none of these work. Well, you probably don't care, but let's say a plus b plus c equals, let's give a value, let's give actual values to these things. Let's say a equals 3, b equals 4, and c equals 5. Happy Pythagorean triple. And then we get 7 plus 5 is 12. So a plus b plus c equals 12. So whatever combination we have, we're going to try to use commutative. We're going to wind up having to have 12. A equals 3, b equals 4, and c equals 5. Let's try that. Let's move this around. Let's make it a plus c plus b equals 12. Well, we're still going to get the same answer, right? Because 3 plus 5 is 7. 7 plus 4 is 12. 7 plus 4, what? 3 plus 5 is 8. That's awkward. 3 plus 5 is 8. 8 plus 4 is 12. Yep. And let's do well, 3 plus negative 3 and equals 0, right? Yeah, that's right. Let's just try to do the associative real quickly. Let's associate a plus b first, and then c. Actually, no, that's what we did beforehand. Let's change that up a little bit. Let's use the commutative property to directly correlate that into that, so we can get something entirely new. And then let's choose the first two, a plus c. Substituting them 3, 5, and then 4. We're going to get 3 plus 5 is 8, plus 4 is 12. But if we were to do it the other way, associating c plus b first equals 12, we'd still get the same answer because a is 3 plus 5 plus 4 is 9, and then we get 12. So as you can see, all these properties, they do work. I mean, I guess you probably assume that they were going to work anyway because I'm showing them to you, and I wouldn't lie to you, would I? So I guess it's not really important unless you're taking an actual pre-algebra class in school to memorize these cases. These cases. Well, I meant to say these properties. But like I've been showing you, an easy way to remember this is commutative. Just means commute, move. Associative, which is the one with the parentheses. Associate, which means to group. Identity is pretty simple. I mean, there's a couple other ones that I omitted. Inverse, and then 0. So these three are pretty substantially easy, just as long as you remember where the 0 goes in some of them. The identity of the 0 and addition are exactly alike. And the inverse property basically means you add a negative inverse, which means opposite, or negative a would equal 0. Okay, so that basically does it for this part. I showed you guys the additive properties. Next part, we're going to go over the multiplicative properties. That'll be fun. See you guys later.